Okay, so we are going to be looking at 2.3, outside of class examples 2.3. So let's paper view. Okay, so this one says biologists have proposed a cubic polynomial to model the length L of an Alaskan rockfish at age A. Um, where L is measured in inches and A is measured in years. Calculate dl dA. So they're asking us to find the derivative at, when A is 12. And then interpret our answer. So if we're going to find dl dA, so when we take the derivative there, we can use the power rule here. And so the 3 will come down and multiply by the 0.0155. Of course, I still only have that TI calculator here. And so that's 3 times 0.0155, which is this. A to the second minus, so you take the 2 down in front and you multiply it, then you take away 1 from the exponent, so that's going to be 0.372 times 2. So this is 0.744a plus, and then the exponent 1 goes down in front, and then you take away 1, so that makes a to the 0, which is 1. So this is 3.95, and the a is gone because a to the 0 is equal to 1. And then the derivative of a constant, 1.21, is a constant, and so that's equal to 0. So I have found the derivative here, and then now what I would like to do is I would like to plug in, so that's the next thing, is to plug in a is 12. So they're asking me to find dl dA at a is 12. So I'm just going to go here and I'm going to plug in 12 for a. And then I'll put this in this put this in this calculator and see how I go along here. So clear, clear, clear. 0.0465 times, well, 12 squared is 144, so I'm going to go ahead and put 144 minus 0.744 times 12, and then plus 3.95. It equals 1.718. So they want us to interpret our answers. Here they want to say what this means. I think it's helpful sometimes to put, remember DLDA is an instantaneous rate of change is what it is, and I think it's helpful to put the units on it. So L was length, and that was measured in inches. So this is inches, and A was stood for age of the rockfish, and in this case that was in years. So this is inches per year. And so I think that what this is then telling us is the instantaneous rate of change in the length in inches at the time 12 years, right? Which is almost, 1.7 inches per year. So that's its growth rate, right? At that inches per year and inches per year at that exact moment. And so right when it's 12 years old, its growth rate is 1.7 inches per year. So, and that's an instantaneous change there. So I'm going to put I'm going to make sure that I put instantaneous and make sure that no one thinks I'm saying average. I have to think about how to spell instantaneous. I'm actually over here trying to look on my phone on how to spell instantaneous without anyone knowing that I'm such a poor speller. instantaneous rate of change in inches per year. That's our unit that we have going. And this is when, I'm going to say when A is 12 years. So right at 12 years, this is the instantaneous rate of change, the instantaneous growth rate right there. Okay, now it says here, the next problem, I have to move my cup out of the way. It says, for what values, problem 88, for what values of x does the graph of this have a horizontal tangent? So if something has a horizontal tangent, that means its tangent line is horizontal. And so horizontal, that's the tangent line. So what does it mean if the tangent line is horizontal? And yeah, I'm hoping that you're saying the slope of the tangent line is 0. So when they say have a horizontal tangent here, they're saying the slope of the tangent line equals 0. So that's when what we're looking for. When does the slope of the tangent line equal 0? So I'm going to find the derivative. And of course, the derivative is the slope of the tangent line. And see, that's 3x squared plus 6x plus 1, right? And I want to know when is that equal to 0? That's what I'd like to know. And I can see that it's quadratic. And so there are two values for x that make it 0. And I might have to use the quadratic formula on that. I don't remember having to use the quadratic formula on it when I did it last semester, but might have changed the problem because the book has changed, and so my memory might not be that good. But here I am saying I can't factor that, and so since I can't factor it, I'm going to have to use the quadratic formula. So A equals 3, B equals 6, C equals 1. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I'm writing a there, but I like to write parentheses. So I like to fill in the parentheses. Anytime I substitute, I put parentheses. So in the first parentheses go b, which is 6, and in these parentheses here go a, which is 3, and 1 is c. If you don't know the quadratic formula, you can go on YouTube and you can watch all kinds of people singing the quadratic formula to Pop Goes the Weasel, if you would like. And so underneath there, I kind of have the zones of cleanup, is what I tell my algebra class. So this is negative of a positive is a negative. Then underneath is 36, take away 12, which is 24, divided by 6. I don't know if this calculator simplifies the square root of 24. Of course, the TI is not the calculator that I recommend. It does actually simplify it. 2 square roots of 6. So I just put the square root of 24 in the calculator. It's 2 square roots of 6. So this is x equals minus 6 plus or minus 2 square roots of 6 over 6. And then this triangle right here, those three numbers have in common 2. And they're all divisible by 2. So I'm going to divide all of them by 2 in this triangle to simplify this. So negative 6 divided by 2 is negative 3, plus or minus. 2 divided by 2 is 1, so that's the square root of 6. And 6 divided by 2 is 3. And so that would be a way of writing those two answers for x, where they have a horizontal tangent. I had it in my mind that we could go on Desmos and put that in. And so I have a way of showing you my MacBook screen. If this doesn't work, I'm going to scream. So that is not showing me the right screen. Can I go here? Here, whoops. Can I click on that? Will it allow me to click on that? No. So I'm already clicked out of that. Yeah, Kev thought that would work, but it is not working. It won't let me click on those. Why is it not doing that? Oh man. Okay. Well, the last thing I wanted to do, pay-per-view, was this, but I'm going to do it. So I'm putting it in on Desmos. I hope you're putting it in on Desmos or your calculator as well. Y equals, or if you're frustrated and don't care to see the graph of it, I guess you could end this video, right? It wouldn't hurt my feelings at all. Plus 3x squared. So I'm putting this in on Desmos is what I am doing. Plus x and plus 3. And so many chords. I don't know if I'll be able to get that over there because there's so many chords. I didn't plug that. Ooh, on accident. What got unplugged? I don't know. Okay, there I have graphed it on Desmos. And then right here at that spot is the place where we have a slope of 0 at negative 1.816. So you remember that place? And then here we have another slope of 0 at negative, so I'm writing these down. Oh, that's my hair going in there. 0.184. And then the other one is right here, slope of 0, negative 1.816. Yeah, sorry about that. I did have, oh shoot, I made it where, oh, there it comes back. Okay, so I just want to make sure I wrote those values that I got off Desmos right here, and I just want to make sure that, hey, those are the x values that I just found, right? So I'm going to put this in this calculator. I don't know how to use this calculator very well, so I have to use parentheses. So negative 3 plus square root of 6. I want that in the numerator. Where's the square root? Square root of 6. Okay, and then I went out to the side, parentheses, and then I want divided by 3. Okay, and then inner, approximately, okay. And so it gave me that one, is what it gave me. So just now, I just put that in my calculator just like I saw it, and it gave me that one. Now, I had just put in the plus 1, so I'm going to put in the negative 1 here as well. And so negative 3, and then minus square root of 6, out to the side, and then divided by 3, hit enter, hit approximately, and it gave me the other value that we had. Remember the other value that we had. So yeah, we went and found those values. Go try some of the homework problems and maybe even look at Desmos on some of them as well, just to see what you found. I think it's kind of fun to see what we found. Okay.